Alright, ladies and gentlemen, I have hope that everyone is alright. Now today we want to look at the Cauchy Euler equation. So we want to see what happens with Cauchy Euler equations also in this format. This equation can be given as we have a2 x squared. This is y prime prime plus a1. This is x y prime then plus a naught. This is x, this is y, then this one must be equal to 0. So an equation of this format can be called an Cauchy equation. In this case, we always say that when it comes to a, anything here, when it comes to a squared, a 2 and a issues of x, these ones must be equal to what? 0. Because the moment they equal to 0, what happens? The whole dA will have to cancel. Like x, if x is equal to 0, this one will be equal. The whole of this and this will become zeros. And now what happens? If a2 is equal to 0, it means that it will no longer be a second order dA in this format. So this one can be written in the first. Someone can continue to write this one prime prime plus a1 xy prime plus a naught y equals 0 and divide all through by a2 x squared over a2 x squared and over a2 x squared over a2 then x squared. So you see that this one cancels, y prime prime plus a1 x. This one cancels and we shall have y that over a2 then x. So now plus this one is a naught over a2, that this is x squared y equals 0. You see that the whole of this one, and this one, we have new coefficients. So an equation can continuously be like that. You can write it like this, or you can have something of this format here, like that you have this in that case. So what happens when you are solving this? Now, when it comes to solving such an equation, what happens? We shall have to let y equals, then if we have solved such an equation, we shall have to let y equals maybe x. Now x we shall have to let a certain parameter. We are introducing something new in this case. So when we let something happen, our x must be the one, the equation, the one we have differentiated to. Then y is the one we have, the function that's supposed to give us the derivative. So in this case, someone is supposed to differentiate this. When someone differentiates this one, gets lambda x, then power lambda, but always the power is supposed to decrease by 1. So you get the second derivative. In this case, it will be lambda, then lambda minus 1. So we shall have x lambda minus what? 2 when you differentiate for the second time. Then what happens is, I have this equation 1, this is 2, then this is 3. So what I do, I'm supposed to substitute equation 1, 2, and 3. So where am I supposed to substitute? Into either this equation or this equation. So I can call this one equation maybe star, and I say that I'm substituting into equation star. So when I substitute into equation star, that's when I'll be able to get my values of m, and I will be depending on the values of this thing. In my case, I have lambda. That's when I will be supposed to get my value of lambda in that case, because now I'll have lambda. So after getting lambda, what happens? There are cases whereby this lambda, you get lambda 1 and maybe lambda what? Lambda 2. When these ones are real and distinct roots. So what happens if they are real and distinct roots? We always let our y be equal to c1, then this one will be x, then lambda 1, then plus c2 y, which is this, then lambda 2, if they are real and distinct roots. Now what happens is maybe lambda and lambda 2, these ones are real, but repeated. Just i.e., if lambda 1 is equal to lambda 2, we always generate it to be what? To be lambda in that case. So what happens is, when you are writing this general format, or the solution in this case, it will be y equals have c1 x to power our lambda. In this case, we have lambda, just lambda. So what happens is, we have plus another constant c2, that is x, which is x by 2 power lambda, then the natural logarithm of the variable we have, which is what? Which is x. This one and this one like that. Then there are cases whereby we have lambda 1 and lambda 2, but these ones are complex roots. So if they are complex roots, what happens? You know what happens. You have dealt with very many issues concerning complex roots. Let us assume that our complex roots, can assume that our complex roots may be is u plus or minus vi in this case. So if it is u or plus or minus vi, what happens is what we want to look at. Alright, we have seen that for example, we say that is to say, if we have these ones plus or minus vi after solving your lambda as this. So what happens? We want to get the solution in this format. We shall say that this one is given by y equals, we have our x at x to the power what? We always power u in this format. Now we get c constant cos. This is you have now your v, but in natural logarithm of the y, which is x, then plus c2, then sine. This is v natural logarithm of what? Of x. This is what we are talking about in this commas. So what happens is, we shall have to look at an example of this format, and we see what happens. We shall have to solve the equation. We shall have to solve this equation: x squared y prime prime minus 3xy, then plus this is prime, then plus 3y equals 0, and we see what we are getting in this format. So what happens is, we shall have to first of all let, as usual, we shall let our, this is now our x by power lambda, differentiate. In this case, we shall have lambda x, then lambda minus 1. Our prime will be equal to lambda into lambda minus 1. This is x lambda minus 2. Now after getting that one, you are supposed to substitute all this one in the equation. So to substitute there, we shall have x squared, where there is this, we have lambda minus 1, then x lambda minus 2 in this case. So after substituting, you go also here, minus 3x, where there is that, you substitute lambda, x lambda minus 1, then plus 3, where there is y, we have to have x lambda, this one is equal to 0. You see that in this case, we have lambda, then lambda minus 1. You see that we are multiplying x squared times x lambda minus 2. Multiplying numbers of the same bases, you have to add the powers. In this case, we shall remain with the x to power lambda, then minus, we have 3 here, lambda, but this is x to power 1 times x lambda minus 1. So what happens is, you have to add the powers and remain with x to power lambda, then plus, this is 3 x to power lambda equals 0. You pull out the common factor here, which is the x lambda. So what happens is, we shall remain with the lambda squared minus lambda minus 3 lambda, then plus 3 in this case, and this one is equal to 0 in that case. So I can have x lambda, then lambda squared minus 4 lambda, then plus 3 equals 0. But we know one thing, that x lambda will never be equal to what? To 0. Why? This is our y. If y is equal to 0, it means that we shall no longer have that equation there. It will have to vanish. The whole of it will have to vanish. So what happens is, this one here must not equal to 0, because it is our y in that case. So we shall have to continue with this, and we say that we are equating this characteristic equation here plus 3 to 0. So when you have that one, we shall have to get the sum. You know very many formulas. Our sum can be -4 product. Our product can be equal to maybe 3, and factors, someone can have 1 and 3 but all of them negatives. So what happens is my lambda 1 would be equal to 1, and my lambda 2 is equal to 3 when you solve that. So after getting my lambda 1 as equal to 1, lambda 2 as equal to 3, I'm supposed to write the general solution, which is in case I must have y to be equal to c1, then y1 plus c2, y2. Now in this case, y is equal to c1, my y1, I write it in terms of x, but this is to power lambda 1, then plus c2, this is x lambda 2. Now I have y equals c1 x power 1, then plus c2, I have my x, but this is to power 3. You see that this is now the solution we are having in this case. Someone can continuously give you something here and tell you to continue. How? Some can even try to give you the particular value. Someone can give you the initial values and try to ask you the particular solution. So when someone gives you initial values, your aim is to now to get the values of C1 and C2 such that you substitute and get the answer in that case. For the moment, let us end here for this. We shall continue from there when we get time. The presentation has been by Santi Soka. Thank you. I wish you the best.